Hi there. Today we're looking at how to add and subtract polynomials, and the essence of why we do this is combining like terms. We're going to combine like terms. So let me show you what this means. Let's say we have an expression like 5x plus 2x. Okay, that's a good expression. Well, we can essentially combine these two terms together by using sort of the distributive property. Essentially what we can do is we can see they share a common factor of x, and we can factor that out. So when we factor that out, we're left with 5 plus 2 all multiplied by x, right? You see how we factored out this common term of x. And of course here we can just add 5 plus 2, that's 7x. Okay, so there we go. We wind up combining these, and we call them like terms because they share this same common factor, okay? Now, if I have another expression, how about something like 5x plus 3y plus 2x plus, let's say, another 3y. Well, here, I cannot combine 5x and 3y. These are not like terms because they do not share a common factor. But what I can do is I can use the commutative property of addition to rearrange the order of these terms. And I can have rearrange it to get 5x plus 2x plus 3y plus 3y. And now you see we sort of have these two groups right here that we can factor out a common factor. We can factor out an x and we can factor out a y here, and that will allow us to combine the like terms inside the parentheses. This will give us then 7x plus 6y. Okay, that's the idea here. If you want to, we can sort of make this blue so you can see all of these are going to be common factors there, like terms using x and y. That's the essence of what we're doing, and what we can do now is apply this to more general polynomials that we were looking at. Essentially, I can sort of take this entire expression right here, and instead of saying, imagining this was a y, what if I imagine this is an x squared? All right. So now that this is an x squared, we'll notice I could technically factor out a common factor of x here, right? I would get like a 5x plus 3x squared, right? I could factor out an x and get a 5 plus 3x. I could do that, but that doesn't help me because then I can no longer combine that 5 and 3x. So once again, I'm going to rearrange the terms using the commutative property, and I'll do it, and I'll get something that should look something like this, right? Except here we're going to have, instead of a y, we'll have x squared. And so of course, when I add this together now, I'm going to just get 7x plus 6x squared. And so now what I've done is I've added all of these terms together, added all the like terms, and this is the essence of how we're going to add and subtract polynomials in general, okay? Essentially grouping together in like terms and then combining them. Let me show you how we do this using sort of the horizontal method of adding polynomials. What we've got here is two polynomials, and we want to add them together horizontally. Okay, so what's the first step in doing this? Well, the first step is going to be to group the like terms together. So let's do that. Notice we have an x cubed for both of these. Okay, so we're going to have some kind of x cubed plus x cubed. And then we're going to have a 5x squared here, and we have a negative 2x squared, so minus 2x squared. Then we're going to have a minus 3x, and then here a plus 4x, and then a plus 7, and then that's all we have. And so what we've done is we've grouped the like terms together just like this. And so once we've grouped them together, then the second step is just going to be to combine them. Okay, so we just want to combine the like terms. And this will give us here essentially 2x cubed, right? And then this will give us 5 minus 2, that'll be a plus 3x squared. Minus 3 plus 4, that'll give us a plus 1x, and then we're left over with a plus 7. And that's it, right? We've done it. We have successfully added together these two distinct polynomials using what we call the horizontal method, because everything is written out here horizontally. Just group those like terms and then combine them. Okay, so the horizontal method, not too bad, pretty straightforward. Let's look at the vertical method. Here we have the exact same two polynomials that we had before, but we're going to add them together vertically. So this is another sort of two-step process, and essentially we just want to align the polynomials vertically in standard form and then add the coefficients together. Let's take a look at how this would look like. So we'll have here an x cubed plus a 5x squared minus 3x plus 7, and then the next one we'll put underneath it, aligning these like terms, right? So we'll get another x cubed minus 2x squared plus 4x, and there's nothing here, so I could leave it blank or I could add a 0, whatever you want. And now we process this just like a normal addition problem. So for example, here we would get a 7 minus 3 plus 4, well, that'll be plus 1x. Here we'll wind up with a plus 3x squared, and here we'll have a 2x cubed. And there we go, right? This is exactly what we got before. Okay, so this is how we can add polynomials vertically together. Let me try and do one more example here just so we can really practice this. So here we go. We're going to have this new polynomial, two polynomials, 4x squared plus 1, and we're going to add that with 2x squared plus 24x. So I'm going to, of course, align these vertically. So I'll have a 4x squared plus 1, and then a 2x squared plus 24x. And that is not going to work, because if we notice, these are not like terms, right? What we should actually do here is we should move this over, because essentially what we have here is we have a plus 0x, don't we? Right? That's really what we have there. And here again, we sort of have this plus 0. So you can write that in. You can write a term with a coefficient of 0 to sort of occupy that space, or if you want, just leave it blank, but make sure everything is lined up correctly so the like terms are stacked on top of each other. And now when we add this together, we're going to get here a 1. Oh, let me get that, a 1. And then here we'll get a 24x, and here we'll get a 4 plus 2 is 6x squared. Okay, so that's how we can do this vertically. They're both options are perfectly valid. You can do it horizontally, you can do it vertically, whatever you want, but just remember to line things up so you have these like terms. If you need to leave a gap or add a 0 coefficient term there, do that just to make sure it's all lined up correctly. Okay, so that's how we can add. Let's look at subtracting polynomials. It's going to be very similar. And here we have the same two polynomials that we started with, but we are subtracting them now, not adding them. So we're going to use essentially the same process as before. Let's try the horizontal method first, but the key here is we want to treat this subtraction as actually the addition of a negative, right? So we want to sort of think of this as a -1, and we're going to distribute that through here and transform this subtraction into addition. And so when we do that, we'll have essentially x cubed plus 5x squared minus 3x plus 7 minus x cubed plus 2x squared minus 4x. Okay, so I've taken this -1 and distributed it through, and these are the three terms we have. And so now it's just addition, and we can just go through the process of grouping the like terms and then combining them. So let's group the like terms. We'll have an x cubed minus an x cubed, right? That's there. And then we'll have a 5x squared plus a 2x squared. That's the next group. Then we'll have a plus a -3x minus 4x x, and then finally we have a plus 7. Okay, and so then we just have to combine these like terms, and I think you can see here these are going to cancel out, so we won't get anything there, but these will combine. We'll get a 7x squared minus 7x plus 7. And there we go. Okay, so that's what we get when we subtract these two polynomials together using the horizontal method. Now let's try one with the vertical method. Here's our two polynomials, the same as we had before, but again, it's a minus sign now, so we'll do it vertically. Essentially what I have here is I'm going to have a 4x squared, I'm going to leave a gap here, plus 1, and then we're going to have a minus 2x squared plus 24x. Okay, and that's what we have, but we're going to do the same thing that we just did here. Is we're going to essentially transform this into addition by distributing that negative in here. So when we do that, we're going to get a 4x squared plus 1, and then we're going to have here a negative 2x squared minus 24x, and here's essentially a plus 0, whatever you want to have. So now we've transformed this into addition. And so we can add this all up together. So 4 minus 2 is going to be 2x squared. Here we just have negative 24x plus 1. And there we are. We have successfully subtracted these two polynomials now using the vertical method. All right. So there we go. That's how we can do addition and subtraction of polynomials. Horizontally, the whole goal is to just group all of the like terms together and then combine them. And if you do it vertically, just make sure that you stack the two polynomials together so that you have like terms in the same column. You should write the polynomials in standard form from highest degree or highest power down to the smallest. That'll aid you in lining things up, and then just add them together. If you're doing subtraction, transform it into addition by distributing that negative sign into the polynomial. All right, there we are. Come back next time. We'll take a look at how to multiply polynomials together. I'll see you then.